Hi class, welcome back. This week we're really going to focus on matrices and their inverses. And just to recap, we talked about a matrix, we talked about its size, rows horizontally by columns vertically, telling us the size. Then we talked about actually labeling where an entry is located. Then we did some operations. We added matrices. They had to be the same size. We subtracted matrices. They had to be the same size. We had a number out front of matrices and we distributed it. And then we started doing matrix multiplication. To start with matrix division, we're going to do basically the same thing as we did with multiplication. We need to do not a compatibility test, but we have to do something that shows if it actually does have a division possible. So today we're going to really focus on the question, can these matrices be divided? Can we divide this matrix? All right, so there actually is no dividing with matrices, but we do have a way around this. So I want to look at the problem 2x equals 8, and I want us to kind of come up with creative ways of how we're going to solve this. So if I told you that you cannot just divide by 2, what would you do to get rid of this 2? Well, the other thing you could do is multiply, which we can multiply by his inverse. The inverse of 2 is 1/2. So by multiplying by the inverse, we can solve without traditional division. So 1/2 of 8 is 4. This is a nice answer. Now, Ms. Freibush, we could have divided by 2 and divided by 2 and just saw that was 4 in the beginning. You're correct, but we don't have a traditional division with matrices. We have multiplying by the inverse. So this guy here is the inverse of 2. This is what we're focused on finding for this kind of math. So, multiplicative inverse, first we need to determine if there is an inverse using something called the determinant. And the determinant is like perfectly named because the determinant determines. It determines if we can divide. A lot of D's there, triple D. The determinant determines if we can divide. Okay, if I give you a matrix A, notice it's a square matrix. We're going to be doing division all with square matrices. Here's an entry A, B, C, D. Yes, we're going to read it across row by row. The determinant is going to be this formula here. Now, if I ask you to find the determinant, there are a couple ways that I'll ask that. I'll say DET in front of the matrix. DET stands for determinant. Also, what stands for determinant is instead of having the brackets around it, these absolute value. Now, we did that when we did vectors as well, when we were finding the magnitude. So it's not new that we have these absolute values meaning something more than absolute value sign. So equals AD minus BC. A and D are your first diagonal pair set. B and C are your other diagonal set. So the determinant determines, I'm going to keep using D's. The determinant is actually the difference of the diagonals, the difference of the diagonals. So the determinant is the difference. Difference just means subtracting of the diagonals. Okay, so if my determinant equals 0, that is the only bad situation. So if the determinant is 0, that's the only number I can't have it be, then there isn't an inverse. Okay, or I'm sorry, if it doesn't equal 0, then there is an inverse. 0 means no inverse. So if it equals 0, no inverse. Why is that? Well, because the formula to find the inverse is this beautiful thing right here. Now, it looks complicated, but we're going to do this in the next video. This says A inverse equals 1 over the determinant. And right here is why my determinant cannot be 0. 1 divided by 0 does not exist. So that means if the determinant ever is 0, game over, we're done. Okay, so because the determinant is used in finding the inverse, since an inverse has existed is dependent on there being a determinant, that is why the determinant determines. Ms. Freibush, you've said a lot of words. Let's actually put some math into this. Okay, friends, so let's try some. We're simply going to find the determinant of the following. And again, there's lots of notations you're going to see. If you see DET, that means determinant. If you see the absolute value signs, that means determinant. If you see a matrix, but the directions say find the determinant, that's another thing that I'm going to ask you to use to find the determinant. Okay, so we're going to start with number 1 here. To find the determinant, again, if you want to have this written on the page, it's right there. Det of A equals the first diagonal, A and D, minus the second diagonal, the difference of the diagonals. So the first diagonal would be 2 and negative 1. So 2 times negative 1, it's the difference, so we subtract. The second diagonal is 8 times 4. So top to bottom, top to bottom. It kind of looks like cross multiplying as far as making that X shape. All right, 2 times negative 1 is negative 2. Minus 8 times 4 is 32. The only number I don't want it to be is 0, and it doesn't look like it's going to be. If I owe 2 and I owe 32, I owe 34. So this guy has a determinant, so therefore it has an inverse. So here is the determinant of this lovely matrix right there. All right, let's go on to the second one. Let's change colors. Again, absolute value signs mean determinant. Determinant is diagonals. 3 times negative 9 minus the difference, 6 times 6. Okay? 3 times negative 9 is negative 27. 6 times 6 is 36. Oh my goodness, I have some math here. If you need a calculator, go ahead, use it. 7 and 6 are 13. Carry my 1. Negative 63 is the determinant. Ms. Freibush, are they always large? No, I promise you they're not always large. It's just for the first two they are. All right, number 3. What about the determinant of this? If you want to just press pause and try it on your own, you can. Otherwise, I'm going to walk through it. Det means determinant. The directions already said determinant. So I'm going to go a little cross multiplication like movements. 3 times 4. The determinant is the difference, which means subtract. 2 times 6. 3 times 4 is 12. 2 times 6 is 12. Uh-oh, my determinant is 0. What does this mean? No inverse. That means that I cannot divide by this matrix right here. All right, let's continue on our path. Number 4, this guy here. If you want to pause, you guys can do these 3 and try and see if you get the same answers as I do. I'm going to go pretty quickly so I can teach you one more thing. First diagonal will be negative 7 times 3, which is negative 21, minus the second diagonal is negative 5 times negative 5, which is 25. Minus 2 negatives make a positive. This is going to be negative 46 is the determinant, which means there is an inverse. That's good. All right, 10 times negative 30 is negative 300. Minus negative 20 times 10 is negative 200. 2 negatives make a positive. If I owe 300 and I have 200, negative 100 will be the determinant. And last one on this page, 12 times 3 is 36. Minus negative 6 times negative 6 is positive 36. Oh no! 0. The determinant being 0 means no inverse. Dividing with this guy is impossible. Okay? Hopefully you guys got those right. Let's move on to the next ones. There's another type of question I'm going to ask you. For what value of x would the following not exist? Would the inverse not exist? Ms. Freibush, it's 0. No. X here is an entry in each one of these. I want to know when the determinant of that guy right there equals 0. So I'm going to set this up like an algebra problem. X times 5. And determinant is difference. 7 times negative 10. And I want to set this equal to 0. When would this not exist? When the inverse not exist? So x times 5 is simply 5x. Negative 7 times negative 10 is positive 70. Two negatives make a positive equals 0. Little algebra, I'm going to move the 70 over by subtracting 70 from both sides. They cancel out. 5x equals negative 70. I'm going to divide by 5, divide by 5. The value for the entry x that is in row 1, column 1 of this original matrix that would make this determinant 0 and the inverse not exist would be negative 14. This is the only number that I would put in here that would make the inverse not exist. All right. Let's try 2 more, and then there's 3 for you to try on your own, but I'll also go through those answers. 3 times 12 minus 9 times x. And again, I set this equal to, if it is not existing, 0. When does the determinant equal 0? 3 times 12 is 36. 9x equals 0. Minus 36. Minus 36. Negative 9x equals negative 36. The only entry that would make this not exist is, 2 negatives cancel out. 36 divided by 9 is 4. All right, let's try one more here. Negative 7 times x is negative 7x. Minus negative 8 times negative 5 is positive 40. Now I'm going to add 40 to both sides. Negative 7x equals 40. This is not going to be a pretty whole number, Ms. Fry, but that's okay. I don't want you to always think that things are going to be perfect. If you want to change this to the decimal, you can. I don't have my calculator right at my hand right now, so I'm going to leave it just like this, 40 over negative 7. It should be about negative 5 point something. All right, so there's 3 more to try. If you want, pause here, but I'm going to quickly go through the answers to these. I'm going to take 5 times 25 minus x times negative 15 and set it equal to 0. So this will be 125 plus 15x equals 0. I'm going to minus 125 on both sides. And, I said I didn't have my calculator handy. I could just divide by 15 on both sides. And I could leave it like this. Or I could go to my calculator real quick. And I could see 125, negative 125 divided by 15 is negative 8.33 repeating. Hey, friend. Okay, let's go on here. 4 times 2 minus 8 times x. Again, I want to know when it doesn't exist, so 0. So this will be 8 minus 8x equals 0. Negative 8x equals negative 8. Divide by negative 8, divide by negative 8, 1. Ooh, I love this one. X times x is x squared minus negative 2 and negative 50 multiplied will give me a positive 100, but I'm minusing because difference. X squared equals 100. Careful here. I know you're going to say 10, but it's also negative 10. Now, I know I'm going quickly. I'm sorry. Here are some extra